Did you know that every single day, over 100,000 commercial flights transport nearly 10 million passengers across our skies? Behind this remarkable feat stands an intense rivalry that has shaped modern aviation: Boeing versus Airbus. These two aerospace giants have dominated the commercial aircraft industry for decades, with distinctive approaches to design, engineering, and passenger experience that reflect their American and European roots. The competition between these aviation powerhouses goes far beyond corporate. Rivalry it represents fundamentally different philosophies about aircraft design and safety. Boeing, with its roots in American pragmatism, emphasizes pilot authority and mechanical reliability. Airbus, reflecting European innovation, prioritizes technological advancement and automated systems. But now, a new challenger from China named Comac is entering the arena, promising to disrupt this long-standing duopoly with ambitions that could reshape the future of global aviation. Spotting the difference. Visual distinctions at first glance. Have you ever wondered how aviation enthusiasts can identify whether a plane is Boeing or Airbus just by looking at it? The distinctions start with the nose. Boeing aircraft feature a more pronounced, almost shark-like nose profile with distinctive eyebrow windows above the cockpit, while Airbus planes sport a sleeker, more streamlined nose designed for aerodynamic efficiency. These visual cues aren't merely aesthetic choices, but reflect each manufacturer's engineering priorities. Further differences become apparent when examining other external features. Boeing typically employs taller vertical stabilizers, providing enhanced stability during challenging weather conditions. Alongside their signature 6-wheel landing gear configuration, Airbus, meanwhile, opts for slightly shorter tails and a 4-wheel bogie landing gear system. Wing design also differs significantly. Boeing favors upturned winglets, while Airbus has developed its distinctive curved wingtip design called sharklets, both solutions addressing the same challenge of reducing drag and improving fuel efficiency in distinctly different ways. Under the metal, engineering philosophies that define giants. What powers these massive flying machines reveals another layer of fascinating differences between aviation's biggest competitors. Boeing typically partners with General Electric and Rolls-Royce for engines that deliver raw power and reliability, while Airbus often chooses Pratt & Whitney or International Aero engines for their efficiency-focused propulsion systems. Engine selection isn't just a technical decision, it fundamentally shapes each aircraft's performance characteristics, fuel consumption, and environmental footprint. Even more revealing are the contrasting approaches to flight control systems. Boeing's philosophy has traditionally centered on giving pilots maximum authority, with computers serving as assistants rather than overseers. Their classic yoke control columns physically connect between pilot stations, providing tactile feedback about what each pilot is doing. Airbus pioneered the fly-by-wire digital approach with side-stick controllers that prioritize computer oversight through sophisticated envelope protection systems that prevent dangerous maneuvers. This philosophical divide, whether to trust human judgment or computer logic in critical situations, perhaps the most profound difference between these aerospace titans: the passenger experience comfort at 35,000 feet. How does the Boeing-Airbus rivalry translate to your comfort when you're soaring through the clouds? While airlines ultimately determine the interior configuration of aircraft, certain manufacturer-specific design elements significantly influence your in-flight experience. Boeing's planes typically feature larger windows that are positioned higher on the fuselage, creating a more spacious-feeling cabin with better views. Their innovative 787 Dreamliner even introduced electrochromic windows that dim electronically instead of using physical shades. Airbus aircraft, on the other hand, boast slightly wider cabin dimensions in their popular A320 family, allowing for more comfortable economy seating arrangements with an additional inch of width per seat. European carriers operating Airbus fleets often capitalize on these dimensions by installing ergonomically designed seating that enhances comfort on long-haul flights. The new challenger, Comac, enters the global stage. In an industry long dominated by Western manufacturers, China's Commercial Aircraft Corporation has emerged as a formidable new contender with serious backing from the world's second-largest economy. The C919, Comac's flagship narrow-body airliner designed to compete directly with the Boeing 737 and Airbus A320 families, represents China's determination to claim a significant share of the estimated $3.1 trillion commercial aircraft market projected over the next 2 decades. The C919 currently relies on CFM International engines, the same supplier used by its Western competitors, which China is rapidly developing indigenous alternatives. What makes Comac particularly interesting is how it blends design elements from both established manufacturers while incorporating distinctly Chinese aesthetic features and cultural symbols. The aircraft's exterior and interior designs prominently showcase Chinese heritage through carefully selected color schemes and artistic motifs. Despite facing challenges with international certification and initial quality control issues, Comac has secured over 1,000 commitments, primarily from Chinese carriers. This emergence signals a potential shift from the traditional duopoly to a 3-way competition that could ultimately reduce costs and accelerate innovation across the entire industry. The future of flight. Innovation in uncertain skies. As we look toward the horizon of commercial aviation, one question emerges above all others. How will these fierce competitors navigate the growing pressure to develop environmentally sustainable aircraft? Boeing has invested heavily in fuel-efficient technologies, with its 787 Dreamliner achieving a 20% reduction in fuel consumption and emissions compared to previous generation aircraft. Airbus has responded with its A350XWB that incorporates over 70% advanced materials, including carbon composites, to reduce weight while maintaining structural integrity. The next battlefield may not be in the sky, but in research laboratories, where engineers race to develop hydrogen propulsion systems, sustainable aviation fuels, and electric propulsion technologies. With Comac bringing fresh competition and additional resources to this innovation race, we may see accelerated progress toward truly revolutionary aircraft designs. Will Boeing's practical approach, Airbus's technological innovation, or Comac's state-backed determination ultimately shape the future of flight? Share your thoughts in the comments below about which manufacturer you believe has the edge in this thrilling 3-way contest.